right, Unit 9 questions for your Semester 2 exam review. Modeling quadratics and inequalities. All right, so the first one is multiple choice. This is a calculator allowed portion of the questions on the test. Number one, I'm not going to use a calculator. I'm just going to talk about the features of the graphs, but you could use a calculator. It says Abigail tosses a coin off of a bridge 112 feet above the ground to the street, which models the height of the coin. Well, think about what's going to happen here. If Abigail's standing on a bridge, right, it's going to be not a great bridge, but she's standing on a bridge, and there's a stream. Right, and then here's Abigail. She tosses a coin into the air. It's going to go up, and then it's going to fall down into the ground. So this is a parabolic shape of the toss, and it looks like it is an upside-down parabola. And when a parabola is upside down, that means its leading coefficient has to be negative. Remember, our quadratics are usually of this format in standard form. It means A has to be negative. So here, my leading terms are negative in options A and C. So D and B don't make sense because those would be opening up, and that's not how we toss a coin. Now, the other thing we have to think about is that it says she tosses the coin from a bridge that's 112 feet above the ground. And above the ground has to be a positive distance, which is your y-intercept. We cannot have a negative 112 because that would be underground. So C is the correct option. All right, number 2. Not multiple choice, we're going to use our calculator. The height of a bottle rocket is given by this equation. T is the time since the bottle rocket was launched. At what time will the bottle rocket be 200 feet above where it was launched? All right, so this asks us a couple things. First, we have to identify where the rocket was launched from, and that's our starting value, our y-intercept, 176. And 200 feet more than that would be at a height of 376 feet. So we want to know, when's the first time that this bottle rocket gets to be 376 feet high? So we're going to graph this in our calculator. And we're going to go to y equals. We're going to first start by graphing the original equation. Remember, you have to use the x's here when you graph. And what I'm going to do is I'm actually going to graph, I think it's going to be easiest, in the second line to graph y equals 376. That way I can just trace the intersection. I'll know exactly the time when I get to 376 feet. So you're going to change your window because obviously when you graph this, you cannot see the graph at all. So I want to change the y's, and it looks like the x's so I can see out. So I'm going to hit window. Let's make our x max. We'll start with 20 just to see what we can see. Y min, negative 10 is fine. Y maximum, why don't we make it, well, if we're going to 376, we want it bigger than that. So I'm just going to try 500, and I'll go by 50s. You can always adjust as you go. But now I can't see the top of my graph, but that's okay. I really only want that first intersection point. That's where the rocket is 376 feet. So I'm going to trace. Second trace, I'm going to choose intersect at 5. And then first curve, I'm going to go, oh, there it is. So I take my cursor back a little bit. I want to be at first curve. So to the left, there we go. So I'm close to the intersection, hit enter 3 times, and it tells you that it intersects at 1.464, comma 376. The time is 1.464, the x value, in seconds. So it's going to take 1.464 seconds for the rocket to be 200 feet above where it was launched, or 376 feet high. So watch the wording there. They didn't ask for when it hit 200 feet higher than where it started. Number 3, we're going to be making a graph. So it says a ball is thrown. The path is given by this equation, negative t squared plus 6t. Graph it and answer the questions. So let's use our calculator. And remember, you have to use x's here instead of t's. So we'll graph negative x squared plus 6x. Now I'm going to go right to my table, and I'm going to plot the points. It says from 0 to 6 was the domain. So we'll plot all these points here from 0 to 6. Go ahead and hit pause on the video. All right, you should have plotted your points. This is the graph that you're going to get. Now, the question, what is the ball's maximum height? Well, the height here, the highest height, looks like 9 meters. I know it's in meters because I looked at the units. What time does the ball reach its maximum height? Well, that seems to happen down here at 3 seconds. After how many seconds does the ball hit the ground? Well, you think about the x-axis as the ground. It hits the ground there after 6 seconds. What was the starting height? Where was the ball thrown from? Well, it starts right here at 0 meters. Now, when will the ball first be when will the ball be at least 8 meters above the ground? Remember, that's asking you for an inequality here. When will you be above that pink line? So the inequality we would write, well, we take the equation of the path of the ball. That's the path of the ball is at least 8 meters high. So greater than or equal to 8. We're looking right here. Well, we can see we intersect 8 at x equals 2 and x equals 4. So our solutions, and I'll write it in both notations here. I'll do set notation first. That means that I'm 8 feet or higher, starting at 2 seconds, until I get to 4 seconds. After 4 seconds, I'm then lower than 8 feet. In interval notation, I would use square brackets. I do that because the at least means 8 or more, which is inclusive. All right, number 4. 2 more questions here. Quadratic inequalities, which were our favorite topic that we did this year. I graphed the inequality for you. X squared minus x is less than 0. So less than 0, remember 0 is the x-axis here. And less than is going to be below the x-axis. So where is the solution? Where's the quadratic less than or underneath the x-axis? Well, first thing I want to point out, the less than strict inequality here is an open dot. So we put open dots at the x-intercepts, and I'm below the axis on this one portion, which is shading one compound inequality in between there. So it looks like I could write the inequality here, -1, and use 2. The x is in the middle, and I have to use strict inequalities around the x. So that matches with option A. Here's another quadratic inequality in number 5. We're going to have to do a little bit more work here. It says, which of the following is the solution to 2x squared minus 7x plus 3 greater than or equal to 0? So first, I need to find the solution. It looks like it's going to be at 1/2 and 3s, but we don't know positive or negative. So we're going to have to factor. 2 times 3 is 6. Two numbers that multiply to 6 and add to -7 would be -6 and -1. So when we factor here, I get 2x squared minus 6x minus 1x plus 3. I'm going to pull out a GCF from each term, and I get the factored form of 2x minus 1 times x minus 3. Now that tells me that I have x-intercepts or solutions at +1/2 and +3. So I'm going to make a sketch here. +1/2, +3. I'm going to have a graph that opens up because the 2 is positive. Again, this is calculator allowed. So if you don't want to factor this, if you just want to go over here to your graph and type in 2x squared minus 7x plus 3, go back to your standard window and graph it and trace the x-intercepts, you can do that. Because if I trace this one, I'm going to see one of my roots is at 0.5. And then I would trace and find the other root at 3. So you can do that. That's totally fine. Now the question is, where are we greater than or equal to 0? That means above the x-axis. Well, this is the x-axis here. It looks like I'm above in 2 parts. I'm going to highlight them to make them stand out a little bit. 2 parts here above the axis, which means I need 2 inequalities. So what I can do is I can actually, because I have 2 parts of my graph that are highlighted, I need 2 inequalities, I can cross off A and C because that's only one compound inequality. B and D, then I just have to make sure my numbers are in the right order. Well, the 1/2 is on the left and the 3 is on the right. So I want all the x's that are less than 1/2 and greater than 3, which looks like option D. I know the compound inequalities are a little bit tricky, but hopefully you remember setting your window for the modeling and factoring, and then using your calculator to trace the maximums and minimums and the intersection. If you need any more help, check the key on Canvas or ask your teacher for help.